Okay. So number 3. All right, so let's see. We're going to do sine A over A equals sine C over C. So I'm going to try and find this angle right now. So that's going to give me sine of 88 over 11 equals sine of C over 5. Okay, we'll go ahead and cross multiply. So we get 5 sine 88 equals 11 sine C. So sine C equals 5 sine 88 over 11. So none of that's difficult, right? Okay, so let's do that on our calculator. We've got, I'm going to do the inverse sine. So C equals the inverse sine of 5 sine 88, bless you, over 11. Okay. So we're looking at the inverse sine of 5 sine 88. Oops, I need some parentheses here. So I'm going to insert parenthesis. And I'm going to do a parenthesis there. Divide it by 11. Did I get that right? Okay. 5 sine 88 divided by 11. Okay. So we get 27 degrees. Okay. So C equals 27. But this is where we get into the tricky part. So anytime we're solving for an angle, we always have to consider the possibility that there are 2 possible triangles. So I have to figure out what that other possible angle is, right? So if we're looking at 27 degrees here, here's my reference angle of 27. Okay, the other reference angle of 27 is going to be right here. So in order to figure out, so basically I'm looking and saying, okay, so I might have a triangle that looks like this instead. So I have to figure out what that angle is, okay? So 180 minus the reference angle of 27 gives me 153. Is that going to be possible? No, that's not possible because this has 88 degrees. If I put this angle here as 153, I'm going to have too many degrees in my triangle. So that means that this angle is not possible. So all I have to do is finish the triangle with that one angle. Okay? So let's look at number 4 and see if that one works out with 2 answers. Does it? No? None of them did? They were all just one answer? Oh, okay. Well, then we won't worry about it. Okay. Does everybody understand how I figured out the 153 degrees? What if it did come out possible? Like, what if, just for argument's sake, that this came out to be like, I don't know, 63 degrees? Is that possible? Yeah. Okay. That's possible. So that means we would have to solve both triangles. We'd have to solve one triangle that has an angle A equal to 88 degrees, an angle C equal to 27. And we'd have to solve another triangle where angle A was 88 degrees and angle C was 63 degrees. And we would have to do 2 separate triangles and figure it all out from there. Okay? I'm seeing some perplexed looks on some of your faces. You're confident with it? Okay, let's move on. Let me call them in so they don't miss this. Okay, so the law of cosine. Okay, again, I'm going to give you the formula. I don't memorize which triangles are going to use it, whether it's side, 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 side angle. I don't bother with that because it just intuitively makes sense, which formula you're going to use based on the information you have. If you try to use the law of sine, you have to have a triangle that has what? Like, what general rule can you tell me with the law of sine? Like, so here's my triangle. How do I know if I can use a law of sine? Sine A over A equals sine B over B, without memorizing the types of triangles. I always need 3 of the 4 parts. So I either need an angle and its corresponding side along with another side, or along with another angle. So, right, if we have A, B, and C, right, if I have angle A and side A, then I either need angle B or angle C. Then I can find side B or side C. Or I need side B or side C. If I have all 3 sides, I cannot use the law of sine because I need to at least have an angle in there, okay? So it's going to kind of make sense when we look at the law of cosine. So the formula for the law of cosine looks like this. A squared, and this is referring to side A, lowercase, right? A squared equals B squared plus C squared minus 2BC times the cosine of A. There's 2 other versions of the same formula. B squared equals A squared plus C squared minus 2AC times the cosine of angle B. Or C squared equals A squared plus B squared minus 2AB times the cosine of C. Those are the formulas for your law of cosine. Okay, the only one you really have to memorize is this first one. Because it doesn't matter which side we're calling A, B, and C, as long as we connect the correct angle to it. Because if you notice the formula, whatever side we have on this side of the equal sign, that's the angle I have on the other side. So A squared is over here, so that means I've got cosine A, which means all the other sides are on this side. If you look at your triangle, okay, look at this first formula. If I have all 3 sides, A, B, and C, what can I solve for? If I have all 3 sides, look at the formula. I have A, I have B, I have C. What can I solve for? Angle A, right. If you have all 3 sides, you can find any of the angles actually. because you could do the same thing in the second two equations. So if you have all three sides, you can use the law of cosine to find your angles. Because remember from geometry, we can have similar triangles, right? Similar triangles with different length sides, but the same angles, right? So I can use the law of cosine here to find an angle. I can also solve for a side. So we can use the law of cosine for side, side, side triangles. We can also use the law of cosine for side, angle, side triangles. Notice that if the given information includes two angles, I can't use the law of cosine. Okay, because I've only got a place for one angle. So just know your formulas and you can tell which one to use. It's kind of a no-brainer because you won't have the information otherwise, okay? So let's look at an example. Yeah.
So you said that the side angle sides can be for cosine, but also when we did it for sine, we had two sides and an angle. So
good. So excellent question, right? So if you look, let's say that I'm trying to find side A, right? So in order to find side A, I need side B and side C, and then the angle that's between them. Side B, C, and angle A. I wouldn't be able to use the law of sine here because in order to use the law of sine, I need side A and angle A. And I don't have both of those. So law of sine, you need to have an angle and its corresponding side to use it. And in this case, we don't. So law of cosine, you can see that angle is going to be wedged between the two sides that we know. It's that side angle side, okay? Okay, so let's look at an example. Let's say that we have this triangle. Okay, we're going to call this A. So side A is going to be 8 feet. And we've got B. And side B will be 19 feet. And C, so side C will be 14 feet. Okay. Let's find the angles for this triangle. Okay. So again, we can't use the law of sine because in order to use the law of sine, I need to have an angle, and I don't have any angles. So I cannot use the law of sine. Okay, so I'm going to use the law of cosine. Okay. So let's work with A first. So we've got A squared equals B squared plus C squared minus 2BC times the cosine of A. I will not give you these formulas. You have to know these formulas, okay? Okay, so that's going to give me A squared, so that's 64 equals B squared, which is 19 squared, plus C squared, which is 14 squared, minus 2 times 19 times 14 times the cosine of A. The biggest mistake I see with these problems is that you do the order of operations wrong. Okay, follow your order of operations. So I'm working with the exponents. 64, see 19 squared, that's 361, plus 14 squared, which is 196, minus 3 times 19 times 14. Oops. 532 times the cosine of A. Okay. So I'm going to add the 361 and the 196. Order of operations, right? 557. And this is where the mistake is always made. right here. We do not subtract those two because this is 532 times the cosine of A. So we can't do 557 minus 532. I'm going to subtract 557 from both sides. So we get negative 493 equals negative 532 cosine of A. Okay, we're going to divide by negative 532. Okay, and I'm going to let you try to finish this one. Okay, so I've got 493 divided by 532, and that equals cosine of A. So how are we finding angle A? Inverse cosine of 493 divided by 532. Okay. Now you can do that all in one step, or you can do it like this. Okay. So I'm just going to take the inverse cosine of that number. So I'm going to use second and then answer. Right, I showed you that the other day, right? And we press enter and we get 22.08 degrees. So A is equal to 22.08 degrees. Okay. Now what? How can I find the other angles? Yeah, now I can use sine. Very good. Because sine is easier to use, right? So now I have side A and its angle, and angle A. So I'm going to do sine A over A equals sine B over B. So now I can use my law of sine. So this is sine of 22.8 over 8 equals sine B over B, which is 19. So we get 19 sine 22.08 equals 8 sine B. So I'm going to divide by 8. And then we'll take the inverse sign. So B is equal to the inverse sine 19 sine 22.08 divided by 8. Okay. And we'll do that on our calculator. Okay, so I get 0.89276, blah, 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 blah. Right, that number doesn't make sense. It's way too small, right? So what do I have to do? Take the inverse sine of that. So inverse sine of that number, 63.2 degrees. So B, 63.2 degrees. And then I can find the angle C just by subtracting from 180. Okay. Questions? Okay. Let's look at another example. These are tedious. They're not particularly difficult in material. It's just tedious. Yes.
I thought when you're trying to find the angle, it's incorrect to round it. When you're trying to find the other angles.
Say that again.
When you are finding the angles, wouldn't it be incorrect to round it because it's not?
We have to round it at some point.
How do you know what point to?
I kind of go with, since we're not told it's a place and we're not worrying about significant figures in this particular case, right? I go with what makes sense, right? This is 222. So, I mean, I could go 22, but it just kind of makes sense to just say 0.2, right? Whereas, I forget what that other number actually was. 22.0. I don't think it was 8. It was actually 7 something, right? But if your answer makes sense, if you rounded it correctly, I'll accept any place as long as you're following instructions. Now, if I say to round it to the 10th, that's the only thing I'm going to accept. Okay. But if not, even if you rounded this to 63, I would accept it. If this was 63.6, that's quite a bit of rounding to round that up to a 64. So I'd want the 0.6. Okay. Good question. Yeah.
So if you haven't done sine, you can find the other angles. If you did cosine, it still all work out. Because I did like the next one, the cosine way, and I got a
Totally different answer. Yeah. And I think that's going to happen. I think you have to use the law of sine to find the others.
So you can only use cosine to find one of the angles?
Yeah. Unless you're sticking with the side, or side angle side. So if you did this to find, like, instead of using the law of sine, let's say you use the law of cosine again to find angle B, right? So then if you use the law of cosine with this formula, that should work actually. With that,
I keep checking it. I keep getting like 116.
did I make a mistake with the law of sine? Did I write my numbers down correctly? Hold on a second.
Can you work it out?
Yeah.
We'll be doing a cosine with. Maybe I must have.
It should work out the same way. Okay. So let's see. Let's find angle B first. All right. AC cosine B. Okay. Good question. Come on. Hello? Just giving me trouble today. Okay, let's try it. So we're going to try and find angle B, right? So we'd be looking at 19 squared equals 64 plus 14 squared, which is 196. 2 times 64 times 196 times the cosine of B. All right, so
Why is it 64 and 196 and not 8? Like, why is it?
I squared them already in my head.
No, for like when you did cosine, isn't it just AC?
It-
A squared C squared?
Oh, did I do that before?
I have no idea.
I wonder if I did. 8, 4, I might have. Did I? I did. I think that's where it messed up. Okay, so 360.
No, you didn't. No, not for A. You just did.
Oh, okay. All right. 64 plus 196, 260 minus 224 cosine B. All right, 361 minus 260, so 101. So we're looking at cosine B, 101 divided by negative 224. So B is inverse cosine. Is this what you got? $116.8. I wonder if I made a mistake earlier. We should get the same answers. Okay, let's see. 116.8. Okay, now let's find angle A, right? So now I'm going to do sine B over sine A. Oh, I don't have to rewrite that. Okay, so that's going to give me sine A over A, which is 8, equals sine B, so sine of 116.8 over B, which is 19. 19 sine A equals 8 sine 116.8. So sine A equals 8 sine 116.8 divided by 19. So A equals the inverse sine, 8 sine 116.8 divided by 19. Okay, check my work, make sure I haven't made any silly mistakes. Okay, let's get rid of all this stuff. And then we'll do that on our calculator. Okay, so we're looking at 8 sine 116 over 8. Right. Okay, and then we're going to divide by 19. And we'll take the inverse sine of that. 22.08. That's what we got for A before, isn't it?
Yeah, so then what would B? Because we got 63 first time and now we got 196.
So we got the same value for A.
The different ones would be.
Okay, so let's work it again then, all right? So if we did it this way, so we'd be doing sine of A, 22.0. Maybe I made a mistake in my calculations. And A is 8, sine B over B, which is 19. So we should get that same 116.8, right? That's what we're saying, right? Make sure I got everything. Okay, so 19 sine 22.08 equals 8 sine B. So we're going to divide by 8, so we get 19 sine 22.08 divided by 8 equals sine B. Okay, so we're going to take the inverse sine of that. All right, let's try it. 19 sine 22.08 divided by 8. Okay, and we're going to take the inverse sine of that. Oh, there's two triangles.
That's what I was
Yes.
just love to do it because I have one.
So, yeah. Oh, well, this is great. Okay. So this comes out to 63 what was it, 63.2, right? But if you look, right, 63.2, the other reference angle over here, that means that I have to also consider 180 minus that, which is 116.8. So we actually have two triangles. We have one where this angle is 63.2. I'm sorry, this angle is 63.2. And this angle down here is 22.08. But then we have another triangle. Can I do this? Let me think. How does it work? Wait, it goes this way. I can't draw it. Okay, wait. My spatially challenged brain is not doing it. It's going to be something like this, I guess. Okay. So this angle is 22.08, but this one is 116.8. So there's two different triangles. That's why we're getting different answers.
So for cosines, do we always have to look for two different triangles then?
We should always be looking to see if there's more than one possible triangle. If they give us two angles, there's only going to be one triangle. If we only have one angle or no angles, there's always a possibility of another triangle. Okay, very good. So let's consider these two triangles, right? So here's the situation. What's the third angle going to be over here? So it's going to be 180 minus 63.2 minus 22.08, which gives us 94. Obviously, this is not drawn to scale, 0.72. Okay, now look at the sides. 8, 14, 19. 8, 14, 19. Is it possible for this to be the correct triangle? Look at the angles and look at the sides. What do we know? How do they correspond?
19 is the biggest side and 63 is not the biggest.
Right, 19 is the biggest side, which means it should be opposite the largest angle. Which means this triangle does not fit the scenario. That is not a solution to it because the largest angle is not opposite the largest side. Whereas on this triangle, we've got 8, 14, 19. So this remaining angle is 41.12. Okay, that's going to work. The biggest angle is opposite the biggest side. So this triangle will work. Remember I told you when we first started this whole unit, pay attention, make sure your angles and sides make sense. Right? So take a look at it afterwards and make sure that it makes sense. Okay. It's a little bit rough, huh? Okay. I'm going to give you a worksheet to practice. All right. So you have to think a little bit, put your thinking cap on when you get your answers and make sure your answers make sense. Yes. Say it. Yeah.
So should we use the law of sine on the other angles or cosine? Or does it
Use the law of sine to find the other angle, but then make sure you check to see if there's another angle you can make.
Or do we have lessons?
Yeah, we're involved. Who's participating in brain walk? Nobody? Are you? Okay. You're gonna hold up the math end, right?
That's called a Charlie.
Oh, okay.
Yeah, not so
Yeah.